Hello. So in this lecture we will be studying how to implement the disk scheduling algorithms using C programming. So these are the disk scheduling algorithms that we have studied in the last lecture. If you want to refer the lecture at this corner of the video. So the algorithms that we are going to implement here are SSTF algorithm, then scan and CLOOK algorithm. So the input required for the algorithm is the number of tracks. So here number of tracks are 100. Then the sequence of request. So this is the sequence of request. Then the head starting position and the direction which is required for the implementation of this algorithm. So let us start with the implementation. So data structure that is required for implementation of this program is we have taken the number of requests variable to count the total number of requests that we have to process. Then track will be the total number of tracks, those are given. Here in this example, total number of tracks are given as 100 tracks. So this tracks variable will store the total number of tracks. Then starting head position, head variable is used. Then to store that temporary, we have used another variable head1. So head1 and head will point to the current location. Then we have to calculate the distance traveled to process all the requests. Finally, we are calculating this distance. So to calculate this distance, we have taken a distance variable. Then to store the all disk requests. So these are the different disk requests 0, 4, 21, 25. These are the different disk requests. To store these disk requests, we have taken an array that will store the disk request, and one will be a finish array which will initially say that all the requests are unfinished, and once the request is processed, the finish array will change. So we have taken 0 for unfinished request and 1 for finished request. Okay, now we have to first read a data. So let us check the main function in which we have called the input function, then the algorithm functions. So let us check what is the input function. Before that, we have called the menu function which will display the menu for you. So let us check input function. Now in input function, we have read the total number of tracks. In this case or in this example, we have the 100 number of tracks. So we will enter the value as 100 here. Then number of requests. In this case, there are 11 number of requests. So we will enter 11, and all the requests we will enter as in the SSTF order. So these are the requests. So this is the number of tracks, then number of requests. These are the request array, and finally we are reading the current head position. So finally we have read the current head position into array as head1, a variable as head1. Okay, so this is the input data required. Okay, now we have to use the second is SSTF, shortest seek time first algorithm. Okay, so let us check how the shortest seek time first algorithm is implemented. So we have declared in shortest seek time first. Let us understand first quickly how the shortest seek time first is implemented. So we have to calculate the difference between the requests. So these are the requests that we have to process. So our current head position is 50. So we will check the difference between this and this. We will check the difference between 52 and 50. We will check the difference between 50 and 61, 67, 87, 89, 90, and all the disk requests. And wherever we will find a minimum difference, that request will be processed. So that is called as the shortest seek time first. So if the distance is required to be traveled is minimum, we will process that request. So first we are going from 50 to 50, then 50 to 52, then 45, then 61, 67, and so on. Okay, so logic here is you have to process the request from the current head position to the shortest one. So for that reason, we are calculating the minimum difference. We will calculate the difference between all the requests. Then pending variable we have initialized to number of requests, because initially all the requests will be a pending one. Then distance we are initializing to 0, and to find the index of which process is to be processed or which request is to be processed. So for that reason we have taken this as the index. Okay, for temporary we will be storing this head1 into a head so that the current head position will not change for the other algorithms. Okay, so we will now process head current head position with the variable as a head. Okay, now first declare that all the disk requests are pending. So pending means finish array for that that request will be a 0. So we have declared 0 finish array for every request. Then first request or the current head position we are printing here with the help of the head, and then we will iterate while loop until all disk requests are processed. We are iterating this while loop until all the disk requests are processed. So while pending is greater than 0, minimum equals to 9999. So we are assigning the maximum value for minimum variable initially. Then for I equals to 0 to number of requests, what we will do, we will calculate the difference. Difference will be absolute difference. So this absolute function is defined into a math.h that you can check. We have included the math.h above. Okay, so we will calculate this difference. Now if that process is not finished and difference is less than the minimum, if difference is less than the minimum, then minimum will change to a difference. Minimum will change to a difference, and we will copy that index, whatever the minimum difference, that index will be copied. So this for loop will check all the differences from the current head position, and finally we will get the minimum difference of the request and the index of that request. Okay, then we will declare that that particular request is processed. Then we will calculate, or we will add the distance. So distance plus equals to absolute value of head minus disk request that is processed. Which disk request is processed? That is pointed by the index. So here we had copied the index. So that distance we will calculate. Then we will change the head position. Now we have processed the request. So now head will be that particular request which we have processed. So that will be our current location. So we have changed the current location here. As one request is processed, we are decreasing the pending by 1, and then we are printing a request which is processed here. Okay, so like this, this while loop will continue for all the disk requests which are pending, and once all the disk requests are processed, then the algorithm will finish and will finally print the distance traveled. Let us check how this program executes. So we will directly run this program. Name of the program is disk.c. So compile this program, gcc disk.c /a.out. Okay, now input data. So we will directly copy paste this input to save the time. So total number of tracks are 100. Then total number of requests are 11. These are the requests, and current head position is 50 that we have entered. Okay. Okay, now this input data we have taken. What input you have taken? Number of tracks are 100. Number of requests are 11. These are the 11 requests in the FCFS order, and this is the current head position. Okay, now run the SSTF algorithm. Enter your choice is 2. So from 50 it is going to 50, then 52, then 45, then 61, then 67, 87, 89, 90, 25, 21, 4, and finally it is ending. And total distance traversed is a 140. Let us check with the manual we have solved here. From 50 it is going to 50, then 52, then 45, 52 to the 45, then 61, 67, 87, 89, 90, and then in the reverse order. And total distance calculated, we are getting it as 140. So this is the shortest seek time first algorithm. Now you can debug this program. Let us try to debug this program. Run, start debugging. Okay. Now it is asking for the input, so we will provide the input here. Then the SSTF algorithm. Okay, now it has started implementing the SSTF algorithm. Pending requests are 11. Finish array for all the requests is 0. Minimum yet not initialized, so check minimum will be now 9999. Then for number of requests, it is calculating the difference. Okay, so first difference is 5 because first request is a 45. Let us check the request. First request is a 45 and our current head position is 50. So 50 minus 45 is 5. So we have calculated the difference as 5. Difference as 5. Then it will change the index as well. So minimum will be a 5 now. Minimum is 5. Index will change to 0. Index is changing to a 0. And then next difference will be calculated. Difference calculated is 17, but 17 is greater than 5. So minimum value will not change. Minimum will remain the same. Now minimum will change when this disk request you will get. So 50 minus 50 is 0 for this. At that time minimum will change. So difference is 46. Observe the difference only. It is 0 now. Now minimum will change to a 0 and index will also change to 5. Check, the index of 50 is 0, 1, 2, 3, 4 and 5. So index is changed to 5. So like this it will check all the remaining requests and difference and finally it will process the request. Now finish of index is equals to 1. It has done. Finish of 5 equals to 1. Then distance will be updated. So distance is updated as 0. Pending will be updated 10. And it will print the head position. Similarly, it will process the next request. Now the difference, minimum difference will be a 5 now and index will be a 0. So request 45 will be processed. So finish index for 7 is changed to a 45. Okay, so like this it is implementing all the differences. Pending will become finally will become a 0 and it will print the request. So this output finally you will be getting. This output finally will be getting for SSTF algorithm. Okay, now we will exit from this. We will not exit. We will check the next algorithm. So let us go for the next algorithm. So let me disable all or remove all the breakpoints. Okay. Now after SSTF algorithm, next algorithm we have to implement is a scan algorithm. So in scan algorithm, how it works, let me show you the implementation of scan. So it starts from the current location and in the given direction. So direction given to us is to the left. Direction given us to the moving in the left direction. So it will move to the left direction and will reach to the end of the disk, that is 0. And from here it will reverse the direction and it will process the remaining requests. So initially we have to find the we have to sort these requests because sorting will help you, because we have to process from 50 to 45 in the same order or decreasing order, and from here we have to process the requests in the increasing order. So for that reason we will be sorting this. Okay, so let us check the algorithm. So index we have taken to point out the current head position, then head, then we have taken the direction here. One more input we have taken as a direction. So we are entering 1 for towards higher disk and 0 for towards lower disk. So 1 for right and 0 for left. 1 for right, let me print here or bracket, higher disk means right and here lower disk means left. Okay. Then we are calling the sort function, so it will sort the disk request in the ascending order. So here we have written a sort function, but you can use any sorting algorithm like bubble sort, selection sort, insertion sort or merge sort. So use any sort, any kind of sorting algorithm to implement this particular sorting. Now check whether this sorting output is correct or not. So this is not required here, but still we have printed to check whether the disk requests are sorted correctly or not. Now next thing is we have to find a location of current head in a disk request sequence. So we have given the current head position as 50. So we have to point out that 50 disk request into a current array, disk request array. So here we are checking whether head is greater than disk request of I or not, or we will say head is greater than or equals to disk request of I. Okay, then we will get the current head position into the index. So here we are printing the index, that is the current head position. Then we are printing head position. Now it will start processing the request. So here we have two cases. If it is going towards right and if it is going towards left. So direction equals to 1 means process request in the increasing order or right direction. So first we are calling a sort function for right direction. Then we are processing the higher request first. We are going into the right direction. That means from the index we will go on incrementing. So higher direction means from 50 we have to go to 52. So here it is the index. So we will have to increase the index to go to the right direction. So we are increasing the index here and we will reach to the final track, or which we will reach to the end of the disk. So from 50 we will reach to a 99. If it is the right direction, initial right direction, we will reach from 50 to the 99. That is the from head to the track minus 1. That is track are 100, track minus 1 is a 99. So we have printed here a last track. So here we are printing the tracks which are coming from the current location in the increasing order. Then we are calculating the distance and then we are changing the head. Then we will change the head to the last track. From last track, what we have to do? From here we have to reverse the direction and process the remaining request in other direction. So we are changing the direction. So we are initializing the index again, and then we are saying I greater than 0 and I minus minus. So it will process the lower request here. Now if direction is reverse, that means if it is a left direction, if it is a left direction. So in left direction also first we are sorting, then we are processing the lower requests. So for processing the lower requests, so this is the algorithm. Here we are at the current position. So we will have to go in this direction. So for processing this request, we will initialize I to index. Then while I is greater than 0, we will go on decreasing the index. We will go on decreasing the index. That means current index is this. Then we will go to the left index, then left, and then left. And so to go to these indexes, we will have to decrease the I variable. Then we are printing here which request is processed, then distance we are calculating, and head we are pointing to we are changing. Then from here we will reach to the end of the disk, that is 0. We will reach to the end of the disk, that is 0. From 0, again we have to process the remaining requests. So we will go to index plus 1. Then I less than number of requests, I plus plus, and then we will process the remaining request, and finally we will calculate the total distance. Let us check how this program works for the same input. Input is same. Input is same. We will not change the input. Only we will run it for the scan algorithm. Scan. Now it is asking for the direction of head. So we will say that according to this algorithm, we have to go to the left direction. That means 0 towards lower disk. So we will enter here 0. So check how it has printed. From 50 it has gone to 45, from 50 to 45, 45 to 25, 25 to 21, 21 to 4, 4 to 0. So it has reached to the end of the disk. Then from 0 it will go to 50 again, 52, 61, and up to end, and total distance traverse is 140. Total distance traverse is 140. Similarly, we will implement for the other directions, scan, and here we will say direction as 1 to the higher direction. So if it is a higher direction, it will go from 50 to 50, then 52, 61, 67 up to a 99, up to a 99. Then from 99 it will reverse the direction and will process the remaining requests, and total distance traversed will be 144 if direction is towards the right or towards the higher disk. Okay, so this is how the SSTF algorithm works, scan algorithm works. Now let us check the implementation of the next algorithm, which is CLOOK. Let us understand CLOOK first. So in CLOOK we start from the current head position and we go to the end of last request in the given direction. So we have given the left direction, so we have come to the last request as 4. From 4 it will reverse the direction and will go to the last request in the opposite direction. It will go to the last request in the opposite direction, and from that request it will go on processing the request in the same direction. So this is the logic. Now let us check how this is implemented in CLOOK algorithm. So this is the CLOOK. We will ask the user to enter the direction, then we will sort the disk requests. We are printing the disk request as it is, and then we are finding or locating the current head position here. So after locating the current head position, we will start processing the request. Now if direction is equals to 1, that means if it is going in the increasing order, and here it is going into the decreasing order. So let us check decreasing order. We are sorting the disk request, then we are processing the lower request. So how to process the lower request? From 50 we will go on processing the lower request up to 4. So here I equals to index, I greater than equals to 0, and I minus minus will process the lower request here. So it is printing the disk request, calculating the distance and changing the head. Now after completing this for loop, what will happen? Your head will be at 4. Your head will be at 4. From 4 you have to go to the last request, that is 90. So here we are saying for I equals to number of requests minus 1, index I greater than index and I minus minus. That means you have to start from here and you have to finish up to this. You have to finish up to this. So we are starting from the last request and then we are coming to the current head position, which is 50. That is index. Okay, and then we are printing the disk request and calculating the distance and changing the head positions, and finally we are printing the distance here. Now let us check the whether it is executing correctly or not for the same input. So CLOOK. Now we will say the towards lower disk. So this is towards the lower disk. So these are the sorted requests, and from 50 it is going to 50, then 45, 25, 21 and 4. 50, 45, 25, 21 and 4. From 4 it is changing the direction and going into the last request in the opposite direction, that is 90. It is going to 90, then 89, 87, 67, 61, 52, and after finishing the last request, that is 52, it will end. Total distance traversed is a 170. Total distance traversed is a 170. Okay, so this is the implementation of the disk scheduling algorithms. Thank you.